button.
Welcome to Art Principles. We're going to recoup some of the stuff we did last week. We're going to talk about how to draw a perfect cube. Last week we did it in two-point perspective, and we will recoup by just going over the same process again. I'm going to start by making my picture plane roughly the same proportion as the drawing, which is your drawing tablet, which is 18 inches by 24 inches. And we're going to create the horizon line in a normal position, which means 1/3, 2/3 are 12 inches, 6 inches. And we're going to establish the line of sight vanishing point right in the center. So this distance right here is 12 inches. This is 12 inches, this is 12 inches. And we're going to establish the two-point perspective vanishing point left over here, vanishing point left, VPL. And when I have a vanishing point that's important, I put a circle around it. Sometimes you have a lot of vanishing points in a drawing, and you'll lose whatever you're drawing. So kind of label everything. This is line of sight vanishing point, LSVP, and this is the vanishing point right. And remember last time I said what you do to draw a perfect cube is you find the station point. In this case, our station point was 12 inches from the horizon line, and normally it would be 24 inches. This would be the normal station point, but that would put the vanishing points way off your page, and it's very hard to draw them off the page. So what we're going to do is move the station point in. Remember, at the station point, you create the 90-degree angle. Create the 90-degree angle. So if I draw a line from here to here, and a line from here to here, this will be a 90-degree angle. This will be a 90-degree angle. This will be 45, and this is a 45. This is the angle that this object makes with the picture plane. In other words, if I'm looking at this, and I extend this one out, this will be a 45-degree angle. And I'm going to arbitrarily, well, before I do that, now what you do to create a 45-degree angle related to these vanishing points here is you measure from here to here. And if you did it mathematically, it would turn out to be 16.9, and so you just round it off. If you just use your ruler, you'll notice usually it's about 17 inches. I think I said 18 inches last time. So this distance here is 17 inches. So I drop an arc up to the horizon line. In other words, I measure from here to here, 17 inches, and I create a construction vanishing point right. And you'll see why I call it a construction vanishing point right in a minute. And I do the same thing to the other side. I measure from here to here, which would also be 17 inches, and drop an arc up here and get construction vanishing point left. So I got my station point here. The normal station point is down here. Now I'm going to draw a cube, a perfect cube. in 2-point perspective. So I'll draw my vertical. Usually when you start off a 2-point perspective drawing, you start with the front edge. So I started my front edge, and I use tracer lines. Go back to the vanishing points. I go from here over here, top, bottom. These lines are supposed to be straight. I'm loosening some muscle control here. These are construction lines. See the difference between the weight of this line and the weight of these lines? These are construction lines. Now, what I'll do is measure this and lay it horizontal, the same length. In other words, whatever, say this was 2 inches. I would draw a horizontal line through the base of this vertical that's 2 inches. And I'd go from the end of that to this construction vanishing point over here, and see where it crosses this tracer line right here. That's actually the same length of this in perspective. So I draw the back of the block. So I've drawn a square in 2-point perspective, a perfect square. And I'll do the same thing to the other side. Measure over here. If this was 2 inches, this would be 2 inches over this way. And I would go to this construction vanishing point over here. And where it crosses this tracer line would be the bottom of the other side. And then I just fill in the blanks. What I mean by that, I start at this edge, and I go to this vanishing point of this line, and this line to be over here. As soon as I get it in, I do the same thing to the other side. So there's my block, perfect cube actually, in 2-point perspective. Now, we didn't talk about it last time, so I'm going to do it tonight. It's fairly easy to do. What we're going to do is draw a block, a perfect cube block, in 1-point perspective. So we'll be using this line of sight vanishing point. That's the 1-point perspective vanishing point. And remember, when anything is parallel to the picture plane, what I mean by that, if I'm looking into this, this will be a square. A perfect square. And the top and bottom of the square will be parallel to the bottom and top of the picture plane. The sides will be parallel to the sides, the left side and the right side. And then I draw my tracer lines back. Now, if you take a square, and you draw a diagonal. Since this splits this thing in half, this angle right here is 45, and this angle right here is 45 to make a 90. This is a 90 degree over here, this is a 90 degree here, and a 90 degree here. So I know that this vanishing point over here and this vanishing point over here are vanishing points that establish a 90 degree with the bottom of the picture plane. So if I draw a construction line over here, wherever this construction line crosses this tracer line here, that's the back of, or that's the top of the block. This is the left side of the block. Then I just draw straight down, and I've drawn a block in 1-point perspective, perfect cube. And if the bottom of this was lined up with the bottom of this, then this back corner would be lined up with the back corner of this first block. Now we're going to one more. You probably never use this, but you might, so I'll talk about it. It's called three-point perspective. What happens when you're in three-point perspective? Well, if I draw a top view, line of sight, and the side view, this is the eye, this is the eye level, line of sight. Remember, the line of sight is parallel to the ground plane. This is the ground plane. This is 1/3, 2/3. This is 12 inches. This is 12 inches. Line of sight. Now, if I look down, in other words, I'm looking down, instead of looking parallel to the ground, I'm looking down. Well, my picture plane, this distance, this line of sight distance is the same, and this is still 1/3, 2/3. But if I'm drawing something in perspective, looking down, then these parallel lines are no longer parallel to the picture plane. In fact, they're moving away from the picture plane. So in that case, since it's moving away from the picture plane, it's my picture plane, normal. What I have to do is create a point of this line right here. This line right here. And when I'm looking straight out, everything is horizontal. All the verticals are parallel to the bottom of the top of the picture plane. But when I'm looking down, they're converging. So I have a vanishing point down here. And the line in front of me will look something like that. I mean, it'll be a sign. I mean, if you're looking at a straight line straight on, you can't tell if it's tipped toward you or away from you. And I go ahead and finish off my line of sight because these vanishing points don't change. In other words, if I go to the top and I'm still looking down, these vanishing points here don't change. What changes is this back edge no longer is vertical, it goes down to this point right here. And on the other side, this one goes down to this point. So this is now a block in three-point perspective. Now, if I look up, in other words, if I change my picture plane to up here, still have 1/3, 2/3. The vanishing point moves along this line up here, and all the lines, all the vertical lines, are going to that vanishing point. So I can't show both of them at the same time, so I'm going to redraw this. Trace lines. This is not perpendicular, but lined up with your line of sight vanishing point. So now this goes up here. This one goes up here. I want to make this a little bit taller. This is the Sears Tower in Chicago, if you're standing on the street looking. In other words, if you look up, all the verticals do this. In fact, find you a photograph and look at the verticals. And if the camera is parallel to the ground plane, all your verticals will be parallel to the sides of the picture. If the camera is pointing down, all the verticals will go like this. If the camera is pointing up, all the verticals will go like this. Now, when it goes like this is called the inferior position. In other words, the viewer is down here. When you do it the other way, that's the superior position. And you can get some kind of emotional things going there. But when we're not going to spend any time on it. Okay, I've just told you about it. You know about it. There's 1-point perspective, there's 2-point perspective, and there's 3-point perspective. Now you know about all 3 of them. You will very seldom use this, but if you have to, you know something about it. Now, if I had a block sitting out here in front of me, and I took a piece of paper and I laid it down above that block, right in the center, and I drew this line on this piece of paper, and I drew this line on this piece of paper, and this line on the piece of paper, and that line on the piece of paper, and stood it up, it would look like this. And if it was a perfect cube, it would be a square. This is called an orthographic projection. If you put a plane perpendicular to the plane of sight, it's an orthographic projection. And this is the top view. If I put a plane over here, that was parallel to that plane, and pulled it out here, this line right here would be here, this line down here would be here, this line over here would be here, and this line here would be here. In other words, and this would be the front view. And I'm going to flip this around. I'll do the same thing, but we'll flip it around. In other words, say we're looking back here. Well, we can do that. plane that's parallel to this back plane, and I project it out. This is called the side view. In other words, this line right here is this line right here. This line right here is this line right here. This line right here is that line right there. Side. Orthographic projection. Now what we're going to do, or what I'm going to do, is establish, I'm going to draw some orthographic projections, and then we're going to draw them. This is 1 unit this way. A unit just means whatever measurement you're going to make it. And it's 2 units this way. And this is 1/2. This is 2 units this way too. So this is 1 unit here, 1 unit here. Now, if I say, look at this corner right here at a 45-degree angle, how would you draw that? Normal, line of sight, 6 inches, 12 inches. Vanishing point left. Vanishing point right. Line of sight, vanishing point. Now I'm going to make this 2 units. Now, if I was using a ruler, I would make this 2 units this way. 2 units this way. And it's 1 unit this way. So I would measure over here. Oh. Construction vanishing point left or right. Construction vanishing point left. Construction vanishing point left would be over here. I want to reverse that. So I draw my tracer lines out. No, I was right the first time. This distance here is equal to that distance there, and this is that distance there. So if I go over here and get this intersection, that's that, that's that side of the block. What I'm going to do is draw this block first and then cut this section here, and this section here out. What this is the change of plane between this plane and the side plane. And it's only one over here, so I'll go over here. So I start out with a solid. Now I'm assuming that this line here, and this line here, there's 1, 2, 3, 4. So what I have to do is, it won't matter. I can do it with this, but I'm going to reintroduce you to how to divide something up into four sections. So I go over here, 4 equal sections. 1, 2, 3, 4. Go up here. You get this intersection here, and this intersection here. Now these get, this is the same length as this in perspective, and this divides it up into 4. So I'll draw a vertical. Notice that these get closer together as they move back. This is a construction line, so I'll get rid of that. I'll measure up here 1 unit. And draw a line from here to here, because this measurement here is the same all the way down. Now, I've got a point here at A, a point here at B, a point here at C, and of course D over here. So I've got a point that I didn't, this is X since I didn't start off there. I would go up to here. This would be point A. I would go down to here, which would be point B. I would go up to here, which would be point C. And I'd go back down to here, which would be point D. And this is the side. This shape right here. Now I'm going to cut these out. And I'll go here over that vanishing point. In other words, this would be A, this would be B, this would be C, and this would be D back here. This point here would be there, this would be X. This would be that point, this would be that point, and this would be that point. So I will draw from here to here. I would go over there. And I would go over there. Then I would go down from there to here till I find that point. So this is what that would look like in two-point perspective. Two-point perspective. Let me draw this bigger and redo that. First thing I did was to draw a vertical that's 2 units, be 2 inches. I can draw it 2 inches. That'd be a 1 inch mark. I would draw horizontal 2 inches, and on the right side, and horizontal 1 inch on the left side. I would draw my tracer lines out. Now, I would go from here, since I want this as long as it is tall, I would use this construction vanishing point over here. I draw a line down through there, hit this intersection. This will be a vertical. So that is the side face. I would go from here over here at this intersection. That's probably correct. Trace a line over there. Trace a line over here. I divide this into 4. Is there another way? Since this is even, is there another way of getting that? Well, I could do this, but you'll have a lot of lines in it, but I'm going to go ahead and do it anyway. I drew the diagonals. Remember, you want to find the halfway point, exit. That divides everything in half. So this was point X, right here. This was point A, this was point B, this was point C, and this was point D. And I just drew, and this line was halfway through. This is halfway, so I go from here to here. Emphasis line there, 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 emphasis line there. Now I can get rid of this, because it's going to disappear. And I draw a line from C, this vanishing point left, and point A, And I go from point X over here, since all of these are parallel to each other. So I can do my emphasis line there. Now here's the kind of the tricky part. What I need to do is find where this is on the other side of that block, and I really can't see it, but I know where it is. I know how to get to it. If I draw a line from B here over to this vanishing point, and I draw a line from this point here back to that vanishing point over there, I will establish the other side of this line. Well, I have this line here directly opposite. I've already got the line at the top, so I draw from here down to that point. That's how I know what this angle is. That's how I know what this angle is. Now we're going to draw a perfect cube. An orthographic projection. So this is the top view. This is the front view. This is the side view. Now what we're going to do is we're going to run a cylinder. Through this cube. It looks something like this. This is the front. This is the side. Start out with our normal 1/3, 2/3, all of this good stuff. Draw my cube. So we've got my cube. Well, looking at this view right here, and this view here, what is this? It's a cylinder that's running through the front face of this. So it's coming through this front face over here. This is the front side. Now, remember, maybe we should go over the cylinders since we only did that last time. I'm going to talk about cylinders over here. Remember that a cylinder is a circle with sides, and the circle in perspective is an ellipse. And if the circle is parallel to the ground plane, the ellipse has a major and minor axis that's parallel to the bottom of the picture plane. And hopefully you had a chance to practice drawing ellipses. The sides are parallel. And as the circle moves away from the horizon line, the minor axis gets larger. Now, if the circle is not parallel to the ground plane, but it's lying on its side, then the minor axis points to the sides of the cylinder. So what I'm going to do is find this, if I'm looking at this is my line of sight vanishing point, the cylinder is on the left-hand side of this block. So what I will do is find the center. Oh, by the way, here's something you need to know. I don't think I talked about this last time. If I'm looking at a cylinder, say I'm standing here and I'm looking at a cylinder, notice that the center of the cylinder is right here. And I'm really only seeing this much of the cylinder. Because past that point, it starts moving away from me. In other words, it's disappearing. So my cylinder is going to be coming, if this is the center point, then this cylinder's, the minor axis of the cylinder is going to be in front of, this is the minor axis. This minor axis is going to be in front of this line. In other words, it's going to be right here. So this ellipse, what I'm going to do is put this cylinder on this block and draw a projection on that block. And then from the block, I'm going to draw out from that. In other words, I'm going to go over here, and I'm going to go over here. And out here, this is this shape in perspective. Remember, the minor axis points to the vanishing points of the side. Minor axis points to vanishing points of the side. We'll do one more. perfect cube, top, front, side, top, front, side. What we have here is a perfect cube with a ball sticking out the top. The ball sticking out the top. Now, if you cut a cylinder in half, I mean a sphere in half, you get a circle. In other words, this is this is what the intersection of this sphere and this cube is all about. So first thing I'm going to do is draw the cube. Since it's a perfect cube, I'll use that vanishing point over there, and this vanishing point, construction vanishing point over here, and get my perfect cube. And since I know I'm not going to be cutting anything out of the front view or the side view, all I'm doing is adding this to the cube. I'm adding this circle to the cube. Now, if I cut the cylinder in half, I mean the sphere in half, it's going to be a circle on the top of this cube. That means that the top of this cube is parallel to the ground plane. So this circle is going to be parallel to the ground plane. So the major axis of the ellipse is going to be parallel to the ground plane. So what I do is I draw the projection of this cube, I mean of this sphere on the top of the cube, and where the corners meet, I draw a circle out of it. So from here to here is an ellipse, and from here to there is a circle. Not too bad. What would you do on the side? Let's say so I have a circle here. Well, I won't see this one. I won't see the one on the other side. So I have a minor axis going over here. I draw a projection. And then I draw a circle. So from here to here, it's an ellipse. From here to here, it's a circle. And if I was going to run a sphere to this side right here, what would I do? I would start out with an ellipse whose minor axis points to this vanishing point over here, then draw a circle around that intersection. Oh, I was going to draw a cylinder. Whoops. Excuse me. From here to here, an ellipse, come out here. This is a cube with circles going out on this side and the back side. Sphere here, sphere back there you really can't see. And a cylinder, so pointed back there. A cylinder running through this direction here. Now what do we have to remember? In this one, the major axis of the ellipse, which is the bottom half of this shape, is an ellipse. The top half is a circle. Here, the front edge of this sphere is an ellipse, since it would be a circle. And the minor axis would be going to this vanishing point over here. And the top part of it is a circle. Over here, I found the minor axis pointing to the sides and drew my cylinder running through it. Okay, we have a cylinder with a sphere on top of it with a transition. So first thing I would do, oh by the way, this dotted line means you can't see it from the top. So I would draw the circle, draw the cylinder. Major axis, minor axis, larger. So what I would do is just right here, you can turn this into a light bulb. Whatever. I think our time is about up. Next time, work on drawing a perfect cube in 1-point perspective and 2-point perspective. And then play around with cutting parts out and adding parts on. That's basically what you always do. Thank you for watching.